Okay. So today we are going to be talking about a very, very important uh, chemical term, mathematical term. And this mathematical term is called the mole. All right. Now, I've been looking over the notes because in the university stream, the way I deal with mole calculations is using something called a conversion factor. And they can be a little confusing to use. So we're going to use good old-fashioned mathematical formulas that we're going to have to maybe do some algebra, some simple multiplication, division, in order to move some things around. I'm going to try to encourage you to use the formula properly, but if you're terrible with manipulating formulas, we can always put it into one of these nice little triangles that some teachers might use in other classes. Have you ever seen that before? So we can do that too, but the math people don't like it when we use the triangles because we're not doing real math. But anyway, we're going to be using some mathematical equations to do this. Okay, before we get to the calculations, let's talk about what a mole is. Now, the term mole might make you think of some little furry character or some little furry rodent that doesn't have very good eyesight, and they eat through my lawn all the time. It's really annoying. But that's not anything what we are talking about here. This mole, this word mole, comes from the word molecule that we've already dealt with, but it's actually a unit of measure. Let me give you an example of a unit of measure that you already know. So, if I have 12 items, right? If I have 12 items, what can I call that group of 12 items for convenience? Let's say I'm selling corn or perhaps some eggs or maybe some dinner rolls, and I group them in 12. What am I going to call that group? What do we call a group of 12 things? A dozen. So a dozen is a convenient group of things, all right? There's actually 12 items or things in a dozen. Does that make sense? So we could say then that in this particular thing that we call a dozen, we have 12 items per dozen, right? There's 12 items in a dozen. Does that make sense? Now, I could go over a whole bunch of other examples. Does anybody know what happens if you have a dozen dozens? It's actually got its own word as well. Any idea? It's actually called a gross. Ever heard that term before? So let's say if you buy pencils as dozens, and a dozen pencils in a box, and then you put a dozen boxes in another box, then it would be called a gross. And that's just a larger number, all right? Now, the mole is essentially a really big number that we use that is like a dozen, except it counts molecules and atoms and ions. It counts the little tiny things we use in chemistry. And because they're so small, the mole needs to be an absolutely huge number, and it is. A mole is not just 12, but it is 6.02 times 10 to the 23. That's what a mole is. A mole is that many things. And we'll be writing these numbers down in a moment. I would never talk about having a mole of eggs. Some, geeky physics people like to calculate, well, what if we had a mole of eggs? What would that get us? You get something like you could cover the whole surface of the earth to like a depth of a couple kilometers worth of eggs. That's how big a mole is, right? So you really can't have a mole of people, right? How many people are on this earth? About 7 billion. Billion is got 3 and 3, that's a million, and another 3 zeros, that's 9 zeros, right? So a billion people on Earth, what are there? 7 times 10 to the 9 people on Earth. This is 10 to the 23. We don't even have close to a mole of people, right? So we know scientific notation, right? We know if that it's got 10 to the 23, there's 23 zeros following that thing. Does that sound familiar to everyone? Because that's going to be important. So a mole is a huge number, and it really only works well for, like I said, molecules and formula units, if they're ionic compounds. And ions, if we're talking about ions. What else is there in there? Atoms, if we're just counting the atoms, like in a group of like gold, like how many atoms. This is such a convenient number that if I have a mole of water molecules, if I had a mole of water, it'd be about that much. That's a mole of water, about 18 milliliters. So the mole is a handy number when it comes to talking about chemicals, because when we have a mole, we have enough that we can see, we can measure, and we can use. All right. Oh, and some chemistry teachers, they get all excited about the mole. Look at here, they even have a mole day. And they say to each other, happy mole day, other chemists. And I don't participate in that because it's really silly as far as I'm concerned. What do they use for mole day? They say mole day goes from 6:02 a.m. to 6:02 p.m. on October the 23rd. And we're supposed to celebrate the mole. Well, we've passed it, so we're not celebrating the mole. And I don't do that. Look, here's some pictures of some people who did mole things. Look at, they did a whack-a-mole. Whack-a-mole. Yeah, I don't know. It's just weird. This is a lemonade stand. They got a mole selling lemonade. I don't participate in this stuff. All right. So what's the mole? It's a really big number. You don't need to write that down again. You can write down this. It is the SI unit for the amount of substance. SI means it's the metric unit. I can measure length in meters, and I can measure mass in grams, and we measure counting things in moles. All right? 1 mole of a substance contains Avogadros number of entities. Avogadros number is this number that I just told you. It's named after the scientist Avogadro because Mr. Avogadro did experiments with gases back in the, I'm going to say, late 1700s. And it was his experiments with a lot of math that other chemists were able to figure out what this special number was. So to pay respect to Mr. Avogadro, we call that number Avogadro's number. We give it the symbol Na. All right? And it has a unit. Let's add the units to it. The unit is very important. It counts entities. I'm going to talk about what we mean by entities. So the unit is 6.02 times 10 to the 3 entities per mole. Please write that in. Because that's going to help us remember the equation. That's going to help us memorize the equation. Because the equation can always be found in the units of the number that we're trying to calculate. Okay? All right. So that's Avogadro's number, 6.02 times 10 to the 23 entities per mole. So what is an entity? An entity are simply those tiny little things that we deal with as chemists. What does my slide have underneath there? Does it talk about what entities are? No, it says the symbols. I don't want the symbol. Let's define an entity. What is an entity? Entities. Entities are the small things of chemistry. All right? So when we talk about entities, we're talking about those little things that we deal with in chemistry. Here's an example. If I'm talking about just say AU, we're talking about atoms. So an entity could be atoms if I'm talking about AU, gold, or potassium, or any of our elements, right? That small thing could be CO2 or H2. Those things are called molecules. So molecules can be entities. I could count how many molecules there are. if I'm talking about something that's molecular. I could have NaCl, or any ionic compound. We call that a formula unit, right? So those are the smallest pieces of ionic compounds. And then I could have even the smaller piece. I could have a Cl minus, or a K plus, or even a CO3 minus 2. And because all of these things have charges, they're called ions. Okay? So that's what entities are. Now, I looked at the note, and I could create the equation in a couple of ways, and you know what, I'm going to actually just keep going. I'm not going to worry about it. Let's go on to the next slide. Don't mind the symbol, don't mind the unit, and don't write that equation quite yet on the bottom. All right? I do want you to write this again, though. Na equals 6.02 times 10 to the 23 entities per mole. And the unit becomes very important. In the equation that the other chemistry teachers use, this N don't write that down, but this N stands for moles, okay? It's the count of moles. This Na is that number, and then this is the entities. But I want you to use the units to help you get the formula. The formula is hidden in the units themselves. We can say that Na, this number, is equal to the number of entities, and I'm just going to write ent for entities, divided by the moles. There is our equation. That's the equation we're going to use. I don't want you to use and worry about symbols. We can use the units themselves to create the equation. So if I have this number, say, written on your test as a data table, you actually can get the equation because Na is equal to entities divided by moles. It's built right in to the units, okay? If we wanted to calculate entities, I would bring moles up to this side. You've done that type of math before, right? Where you multiply both sides by moles, bring it up to this side. So I could then have entities is equal to Na times moles, right? And if I wanted to find moles, I'd have to bring moles up here and Na down there. Moles would be equal to entities divided by Na. Those are the rearranged versions of that. Because some of us don't like math, we build this triangle. I'm going to ignore this triangle here. Do we know how to make the triangle? Do we know the way the triangle works? When you build a triangle like this, right, remember, these two get multiplied together. It's like we've got a times in here, and then above and below, they get divided out. Does that sound familiar? So if you've got a version that looks like my top one, entities divided by moles means I can put entities divided by moles. Ent divided by moles. Notice here, ent divided by Na, ent divided by Na. And then notice here, these are multiplied together, okay? Remember, Na is that number, 6.02 times 10 to the 23, and I apologize for messing that up. So what we're going to be doing now is, we're going to be looking to calculate moles or entities. And because Na is a number, we're never going to be asked to calculate that. We're just going to be using it. What do you think? Na is 6.02 times 10 to the 3 entities per mole. That allows me to get my equation. Na equals entities divided by moles. Let's do some examples. Yeah, they like to use the N for moles, and entities, writing that out is just way too much. I like to use moles for moles, because that's what we're trying to find. So the question is, and I don't like this, I like to write moles and Na. It doesn't matter which end they're on, right? It doesn't matter whether we flip those around. They're the same thing, right, on the bottom. Find the number of entities in 5 moles of a substance. We don't know what the substance is, so we don't know what the entities are. We don't know whether they're atoms or molecules or formula units, but we don't care. We're just looking for how many of those little pieces there are. We know how to use the triangle here for this. If I'm looking for entities, I'm covering up entities, right? We're multiplying those two things together. Entities is equal to moles times Na, or Na times moles. Entities is equal to Na times moles. Na is 6.02 times 10 to the 23 times 5.0 moles. Now we've got some calculator practice to do. All right. I'm going to put an equals way down here because I'm going to put some notations up on the board. We'll do that in red. Now we need to know how to use our calculators. Everyone pay attention here. Some of you are already firing them into your calculators, but I'm sure some of you are going to make a mistake on how to use them. When you have something like scientific notation, you do not ever press times 10, all right? In our calculators, there is a special button that takes care of times 10 for you, and you must use that button to prevent mistakes in the future. That button that gives you the times 10, if you have a Texas Instruments, is going to be EE. But those calculators are slowly moving away. I know I gave out a few Texas Instruments. If you've got a Sharp or a Casio, you're looking at EXP, the EXP button. All right? Has everybody found their EE or EXP button? We got it? We got it? Got it found? Good. So this is how it goes into your calculator. 6, and I've lost a decimal here. 6.02. Do we know how to put in 6.02? Okay, good. Because the point, that's the dot button, right? You know where the dot button is? Okay, good. I'm making fun, by the way. 6.02. Then press EE or EXP. Do not press times 10 and then EE or EXP. Okay? Because if you do that, your answer will be 10 times too big. You'll push times 10. And this has it built in. Then put in your 23. Then you can press times, because that's what we're doing. And then you can press 5. You can put 5.0. And then you can press equals. And then you're going to tell me what the answer is. So what are we looking at, Conrad?
I got 3.701 to the power of 24 times 10.
By the power of 24. And you don't have a times 10 at the end of it, do you? What have you got here? Ah, all right. See that little times 10?
Yeah.
That's the times 10 that you told me right there. So you've told it to me once. That's exactly nice. Correct. And the answer is, well, what did we just find? What is the units that we just found? What did we just calculate? Entities, not overmoles, just entities. You might want to know where the moles went. Let me show you where the moles went. This actually has a unit of, and I'm going to change the color one more time, entities per mole, right? That mole cancels out that mole. A little bit of unit mathematics, which leaves you with entities. Don't worry about what I did there if you didn't understand how we canceled those units, but that's where the units went. Okay?
Numbers.
Yeah, and this equals Entities, right? That's why I wrote it as that, because that's then the unit on the end, entities. Okay? It is weird because I'm not using a variable. I'm using the unit as the variable. If you don't like it, you can go back to conversion factors. Okay. All right. Let's do another one. Let's now find the number of moles. Oh, are you kidding me? 152 molecules? That's going to be a tiny little number, but that's okay. We're all right. So 3.01 times 10 to the 24 entities, little tiny things. Again, I like to write down moles and just ENT. Find the number of moles. I'm looking for moles. I cover up moles, entities divided by NA. All right? And I want black back here. Find the number of moles. Moles equals entities divided by NA, my big number. Molecules. Molecules is an example of those tiny little things. Molecules is entities. It's not moles, it's entities. They're tiny. 152 entities of that substance divided by Avogadros number. Do we have it memorized yet? Anybody memorized Avogadros number? No? All right. 6.02 times 10 to the 23. So 152 divided by 6.02 EE or EXP 23. Here's an example of where if you didn't use the EE or EXP, it would mess you up, because as soon as you press times, it would put the 23 up top here in your calculator, and it would mess it up. So as long as we did it correctly, Jessica's looking at a number right there. What are you looking at? 5.2? Okay. Times 10 to the negative 22. And what did I just calculate? Moles. You got times 10 to the positive 24, because you didn't use ENT or EE or EXP. You pressed times 10. You pressed times 10. You had to have. You had to have. Well, I don't care. Okay. This is what we got here. Okay, let me advance to the next one, and then you can come up and show me what you did. Click, click. Come on up. Show me how you put it in your calculator.
Put it in as 152 divided by 6.02.
No.
No, EE.
Yes, there is. Right there. EE. So that's something different again, which messes you up. That's okay. It's all right. Again, I like the idea of moles and ent and Na. So it says find the number of moles. That determines your equation. Are you going ahead of me? Have you already done? Have you done, Conrad?
I'm on this. I'm caught up on this.
Like you're way ahead. You've like calculated all of it.
Yeah.
I'm boring you. So you're watching ahead of me. Oh, you're doing the next. You're doing this next stuff. That is crazy. He's like doing the stuff I assigned for the next 2 days. Conrad's going to be like done for days. He's learning 3 things at the same time. It's exciting. That's not doable. No. What equation is it? Somebody tell me the equation to write. Bethany. She's way back there. I like picking on her. What do you got? Yep. Formula units is an example of entities, right? So I can put that right in there. 2.53 times 10 to the 25 entities. 6.02 times 10 to the 23. Why isn't the hand shooting into the air saying, ask me, ask me? Oh, okay. I make fun of you on the video, by the way, in the next videos.
Oh, yeah, what is it?
Nothing. Have you got an answer?
I didn't touch it.
Okay. Yep. It's because she made a mistake on the last one. She didn't like it. What do you got?
4.20.
And times 10 to the times 10 to the 1? 4.20 times 10 to the, and you don't need to put 0, 1. You can just leave it as 1. And that is, what is the unit? What did I just find? Moles. Says it right at the front. Moles. That's scientific notation. That's fine. Your calculator is set for scientific notation. Some calculators that have this, that weren't set for scientific notation, would have this times 10 to the 1, this moved over 1. You probably have 42 moles. All right? This calculator was set for scientific notation. That's fine. I know what that means. And 42, I know what that means as well. Either way, doesn't matter. It's just that when we were playing with the settings before you borrowed it here, type deal. Click. Now, at this point, we've got a question sheet to work on. I'm going to let you work for about 10 or 15 on some problems, okay? And then I'm going to talk about something called the molar mass. It's very much like the formula mass, except instead of it being one molecule, it's a mole of molecules. What's the mass of an entire mole? So we're going to stop there for a moment. I'm going to let you work, and then I will come around, make sure everybody's got the idea, and then we will we'll do the second part of this little lesson. And I'm going to stop my recording here.